Image formation by mirrors. So what are images? When you look through a mirror or lens, you see an image of things. To understand the formation of image, we must understand how the path of light beam is changed when it encounters a boundary like a mirror or a lens. Our brain believes that light travels in straight lines, which is why when we look in the plane mirror, we think that the image is located behind the mirror. There are two basic types of images. There are real images and then there are virtual images. Real images are those formed by real light rays that converge at a real focal point, so the image can be thought of as real. It can be projected onto a screen because light is actually passing through the point where the image appears, and it's nearly always inverted. Virtual image is the image formed by a plane mirror, also in some cases, as we will see, by curved mirrors and lenses. It cannot be projected onto a screen because real rays do not go where the image is seen at. Okay, the image only appears to be there. So some properties of a virtual image, a little bit of a harder concept to understand. No light is actually passing through the apparent location of the image. Actually, for the case of plane mirrors, the image might appear in a location where the light cannot possibly travel. The image cannot be focused onto a screen. To see the image, you must look into the mirror or the lens. The virtual image, so imagine if you have a mirror and you're standing here, it seems like the image is formed back here. But when you go behind the mirror, there's nothing there, right? Because the image really isn't there. So that's a virtual image. So a virtual image can be produced by a single mirror or lens, and it is always upright, not inverted. However, systems with several components can produce virtual image that may be either upright or inverted. But again, it has to be several components, as we will talk about later. Real image is in which the light rays actually pass through that spot, so the image can be focused on a screen. A real image can be produced by a single lens. It's upside down. However, systems with several components can produce real images that may be upright or inverted. Now here's an activity I want you to do at home. So take a metal spoon from the kitchen drawer and hold it from about a foot from your face, the hollow side facing you. You should see an inverted view of your face. That will be the real image that is actually located in a space about 1 centimeter in front of a spoon, depending on whether you have a teaspoon or a tablespoon. Now, turn the spoon over. You will now see an upright view of your face. That is the virtual image which is located behind the spoon that you are seeing right now. Now let's talk a little bit about plane mirrors. Plane mirrors always give you virtual images. So for example, if you have this object here and you are looking at the reflection of this object through a mirror, you will feel like that image, that this object is actually here. So if there was something that was blocking the path here, what you will see is that image is actually located here. So, hall mirror, the real you with a mirror. And the image. Do you see what happens? I'm going to do this animation one more time. The real you is standing in front of a mirror that is half your size. You see this, then you see this, and your brain thinks that even with half a mirror, you are completely full on the other side. Like that. So, a mirror only needs to be half as tall as you, and your image will be twice as far as it is from the mirror. So if you are, say, 1 meter in front of the mirror, your image will be 1 meter behind the mirror. If you move closer to the mirror, your image will move closer. If you move away from the mirror, your image will move away from the mirror. Also, we've heard this term before, mirror image, right? So when you look at yourself in a mirror, your right hand becomes your left hand, and that is called an image reversal. Another cool aspect are called spherical mirrors. Spherical mirrors are mirrors that aren't flat. So the light still follows the same rule with the same local surface normals, and light will be able to focus at a certain point. So with parabolic mirrors, with incoming light, which is completely straight, will be able to focus at the focal length of this mirror here, as shown in this picture. Parabolic reflectors are really, really important. For example, they are used in satellite navigation. They are used also in old flashlight cameras or in new flashlights. And part of the reason is because they're parabolic. One of the interesting things is not only do they collect things from far and focus them, but if something was located at the focal point of those mirrors, it actually, once it hits the lens, it actually reflects back to being straight. Not only do this image go that way, but it also goes backwards. So if there was an object located here that was shining, then the rays that are going to be forming are going to form outwards. That's amazing. There are different types of mirrors. One is called a concave mirror and the other one is called a convex mirror. Concave mirrors curve inwards, convex mirrors curve outwards. Here's a focal length shown by parallel rays coming in to hit a parabolic mirror. You can see these lines coming in from here will all focus at one spot right here. That spot on which all the light coming from the mirror focus is called the focal point. I want you to take this in because it's going to help us figure out what we need to do. Convex mirrors and concave mirrors. Convex mirrors, the focal point is positive. It is a converging mirror. That means it brings light together. There are three main rays that we are going to talk about: parallel, chief, and focal. Parallel ray starts at the object, goes parallel to the mirror, and then goes through the focal point. The chief ray strikes the middle of the mirror and it's reflected back, and the focal ray goes through the focal point and then it diverges back, and it hits and it's reflected back parallel to the optical axis. Concave mirrors are negative. They are diverging mirrors. They diverge the light away from you. So an image formed by a concave mirror will look like this. You will have an object, hits this mirror, goes through the focal point. That is going to be our parallel ray. This is going to be our focal ray, and our chief ray will go from here, hit the center, and reflect back, and the image will be formed right here. So images formed by a convex mirror, same thing will go here. It will hit the mirror, be reflected back going through the focal, hit the mirror. This will be our chief ray. This will be our parallel ray. In this scenario, for our focal ray, it will go and it will hit the focal point, but it won't cross the mirror, so it will be reflected back going this way, and this is where the image will be formed. And don't worry, we will do examples. One of the things that's really useful is called the mirror equation, which basically is 1 over f equals 1 over I plus 1 over O, where this is going to be called our optical axis. This is our principal ray, our focal ray, and it will form an image right here. For magnification, we are going to use h prime over h or I over O, which is basically the height of the object or the height of the image, or the object image distance over the object distance. That will give us magnification.